We have considered most of the elementary transformations. Let's take care of the last bits. What's going on when the graph of a sine or cosine is compressed or stretched horizontally? So here, the blue function here is a sine wave that's been compressed, and here, the blue wave is a sine wave that's been stretched. If you're connected to the internet, click on the hyperlink below for a Desmos simulation. There are two graphs. One is f of x equals sine x in red, and the other is g of x equals sine of bx in blue, for changing values of b, where b is between 0 and 5. Let's consider the cosine function and a set of numbers inside the parentheses as shown below. Describe a set of inputs that produces a complete cycle. Discuss. If you replace the question mark with x, then f of x equals cosine x. We know that a cycle is achieved for any 2 pi interval, including x is greater than or equal to 0 and less than or equal to 2 pi. What happens if the inner function is bx? F of x equals cosine of bx, where bx is greater than or equal to 0 and less than or equal to 2 pi, which then, if you divide each piece here by b, we get 0 is less than or equal to x is less than or equal to 2 pi over b for a complete cycle. Stretching the graph of sine x horizontally away from the y-axis is given by g of x equals sine of bx provided b is between 0 and 1. bx is greater than or equal to 0 and less than or equal to 2 pi implies that x is greater than or equal to 0 or less than or equal to 2 pi over b for one cycle. Consider f of x equals sine x and its transformation g of x equals sine of 0.5x. So here, x is greater than or equal to 0 and less than or equal to 4 pi. That's the new period of sine of 0.5x. Compressing the graph of sine x horizontally towards the y-axis is h of x equals sine of bx provided b is greater than 1. bx is greater than or equal to 0 and less than or equal to 2 pi implies that x is greater or equal to 0 and less than or equal to 2 pi over b for one cycle. Consider f of x equals sine x and its transformation h of x equals sine of 2x. So here we divide each portion by 2 and we get x is greater than or equal to 0 and less than or equal to pi. That is the period of sine of 2x. The period of sine of bx and cosine bx is given by period equals 2 pi over the absolute value of b. So the period of sine 2x is 2. This is false. If we have 2 as our b value, to find the period we have 2 pi over b, which is 2. Those cancel and our period is pi, not 2. So this is false. The period of 2 cosine 0.25x is 8 pi. This is true. We can ignore this a value out front. Here we have 2 pi over b, which is 0.25. So this is 1/4. So instead of 2 pi divided by 1/4, we can have 2 pi times, and then we flip the fraction, 4, so that is 8 pi. So that's why this is true. The period of 5 cosine pi x is 2. All right, so we have 2 pi over b, 2 pi divided by b, which is pi. The pi's cancel. We are left with 2. This is true. The period of cosine pi x over 12 is 24. So we have 2 pi over b, 2 pi divided by b, which is pi over 12. Anything that's surrounding this x is going to be the b. So we have pi over 12. So what we want is then we can say that's 2 pi times, and flip the fraction, 12 over pi. The pi's cancel. 2 times 12 is 24. This is true. False, true, true, true. Let f of x equal 3 plus sine x. For each function below, write a rule for the new function after the given transformation. Is this a horizontal compression or stretch, and what is the period? F of 2x is 3 plus sine of 2x. This is a compression, and to find the period, we take 2 pi over b, and in that case that's 2. The 2's cancel, and the period is pi. And this is a compression, I'll write that. All right. For f of 6x, that equals 3 plus sine of 6x. This is another compression since this b value is greater than 1. And the period is 2 pi divided by b, which is 6. Therefore, the period is pi over 3. And here we have 3 plus sine of x over 3. And this is a stretch because our b value is 1/3. And the period is 2 pi divided by 1/3, which equals 2 pi times 3, or 6 pi for our period. There are the answers. Let f of x equal 2 sine x. Its graph is displayed. The function g is given by g of x equals f of 0.5x. Carefully sketch the graph of g of x on the grid. Write a formula for g that does not involve f. Okay, so what I'm going to do is pick an x value. Let's start with pi. G of pi equals f of pi over 2, because we take that pi, multiply it by 0.5. Therefore, whatever the value is at pi over 2 on the f graph, that value is now going to be the value for g of pi. So this point has moved there. All right, so let's pick another point. How about this minimum here, this 3 pi over 2. So g of 3 pi over 2 equals f of 3 pi over 2 over 2, or we could just multiply by 1/2. So this becomes f of 3 pi over 4. So what is f at 3 pi over 4? So that's 3/4 pi. So this value here is now going to be the value at 3 pi over 2 here. All right, so this point has moved there. Now what about 2 pi? G of 2 pi equals f of 2 pi over 2, or just pi. So this point has now moved over to here. All right, what about the point, let's plug in 3 pi. G of 3 pi equals f of 3 pi over 2. So at 3 pi over 2, we have this point. This is now moved to 3 pi. So if we sketch our graph, we have something that looks like this. Write a formula? Well, okay, so we can just plug in g of x equals 2 times sine of 0.5x. So we've just plugged in 0.5x here. And here in green is our new graph of 2 sine of 0.5x.